Okay, so one last video for math. I do not believe that I can record our final exam review. I will try to check on that, but chances are those will have to be in class only. All right, let's get started on this one. So remember, we want to figure out the perfect square, so that would be 5 squared. We have a match between our index and our exponent, so we can just do plus or minus 5 for this one. It's an even index, so we can do the plus or minus, whereas with the odd indexes, we want to leave the sign as is, depending upon what they give us. Now here, we have a negative outside, so we'll just go ahead and leave it as a negative. So that's going to give us a -7. There is an error on your printout. I should have written 1331, and I accidentally wrote 1339. So go ahead and fix that, and that will give us a solution of the cubed root of 11 cubed, which gives us 11. And then the fourth root here is 8 to the 4th power. So again, we could do plus or minus 8. I will also accept just 8, just like back here. I will accept just 5. Okay. All right, if you plug this into your calculator, you should get about 28.548. Right. Put that in one of my boxes. Remember here, the denominator becomes the index and the exponent stays the exponent. So we'll make it the 5th root of xy squared, and I will leave it as that. So guys, it's like 4 o'clock in the morning. I could have swore I just heard somebody coughing in my living room, but I'm home alone. Pretty sure it was just ice cubes falling in the tray. Still scared the crap out of me. All right, so here for this one, remember again, denominator becomes the index. And if you guys put some of these answers in absolute values, I won't take off any points, but I don't believe you need them. So just throwing that out there. Here you can actually do this one in 2 different methods. You could just see it as, you could be able to see this as q to the 12th, and then we're raising it to the 1/2. So that'll give you q to the 12th divided by 6. Or sorry, I'm getting ahead of myself. Q to the 12th divided by 2, which will give you q to the 6th. That is the same as if we were to say, okay, let's take it a little bit deeper or longer. So q squared, q squared, that's to the 4th, to the 6th, to the 8th, to the 10th. 1, 2, 3, 4, 5, and to the 12th. So we're pulling out 1, 2, 3, 4, 5, 6 pairs of q's. Again, q to the 6th is your answer. So either approach there is fine. Here we're going to be adding because we are multiplying. So that's y to the 7th plus 3. Your LCD is the same, so you don't have to worry about that. You actually end up getting y to the 10 over 10, which is just y. Now, I should warn you that for number 10, my answer is a little bit different than what your answer is going to be on the test, in that mine cancels out again to be a whole answer, 1 over 1. Yours is a little bit different, so just pay attention. What you basically need to know is that when you're dividing, you're subtracting the exponents. So here we get 4 minus 1 over 3. So it's 3 over 3, which is just x. So I wanted to bring that to your attention. Here, using the product rule, we're going to take 15 times 3. That ends up giving us a square root of 45, but we can break that down into 9 times 5, which is 3 squared times 5. So that's 3 plus or minus 3 square root of 5. Okay. Here we can split this to be square root of 16 over square root of 81. So that's square root of 4 squared over square root of 9 squared, sorry. 9 squared, which will give us plus or minus 4/9. Here, remember, this is the square root of 25 times 2, which gives us square root of 5 squared times 2, which gives us 5 square root of 2. And really, if we want, we can squeeze the plus or minus in the front. Sorry, guys, sorry. All right, here, we have to use the Pythagorean theorem. So a squared plus b squared equals c squared. We have our c, and we need to find b again. So find b. So I'll subtract a squared on both sides. I'm also going to take the square root. So it's going to be c squared minus a squared. So then b is equal to, in this case, we have a c of 12 and an a of 8. So it's going to be 12 squared minus 8 squared. So b is equal to 144 minus 64. So b is equal to the square root of 80. And then we can split that into square root of 16 times 5. So that's b is equal to the square root of 4 squared times 5. So what we really have is b is equal to 4 square root of 5 units. And remember, with applications, you need your units, even if they don't give it to you. And when you are dealing with the length, it is a positive length. Okay, here we would do the combo on the outside. Size 11, square root of 19. All right. Going good, guys, going through it. I would watch this a few times. Make sure you work it through with your review sheet if we don't finish it in class or don't get to it in class. It is pretty similar to what your test is. Here, we're going to do x to the 4th times x times y minus 3x. And that one doesn't change. So then we get x, and we're pulling out an x here. You'll notice that the variables match and the radicands match. So I can pull 8x minus 3x to the front. And I end up getting 5x, 4th xy. Keep it going, keep it going, keep it going. All right, so square root of 3 times 11 minus square root of 11 times 11 minus 3 times square root of 3 plus 3 times 11. Right. Cool, yeah. So square root of 33 minus 11 square root 11 minus 3 square root of 3. Fix that a little bit for you. Plus 33. Okay. Can't do anything else with it. You are going to have one with 4 as well, so just pay attention. Here we need to do a rationalization, or rationalizing. So we do that boot method. You end up getting 4 square root of 3 on top, and the bottom is 3 times 3, or 3 squared. So then you end up getting 4 square root of 3 over 3. All right, so for 19, you're gonna have to do a rationalizing with the conjugate of the binomial. So boot method again. Here it's going to be 8c minus the square root of 2y, square root of 8c minus the square root of 2y. Okay, so we would get here 8c squared minus 8cf plus 2yf minus 2yc all over 8c squared minus 2y squared. So then that we pull the c out, 8 minus 8cf underneath plus 2fy minus 2y cy. I mean, it really doesn't matter which way you write it, but, and then when we pull it out, we get 8c minus 2y. Okay, yours will be very similar. So again, I would pay attention to these and make sure you work them. Here you just need to find the GCF, and that is equal to 7. So 56 divided by 7. So divide everything by 7. We get 8 plus 3 square root of 20 over 7. Square root of 20 can actually simplify too. It's 4 times 5, which we know that's 8 plus 3 times 2 squared times 5 over 7. So final answer, 8 plus 3 times 2 is 6, square root of 5 over 7. All right. If you need me to, I can squeeze in that little bit of extra work. The 8 plus 3 times 2 square root of 5 all over 7. Okay. All right. Another semi-easy one, square root of 225 times square root of -1. That is the square root of 15 squared times square root of -1. So that's 15i. Technically, we can have a plus or minus outside of it. Okay, we got to FOIL this. So 6 times 11 minus 3i times 11 plus 5i times 6 minus 3i times 5i gives me 66 minus 33 I plus 30i minus 15i squared so that gives me 66 plus minus, we'll do like this, plus oh, that's just awful. All right, let's just combine these parts first. So that's going to give you minus 3i. And then here we get minus 15 times a negative 1 from the I squared. So recall that should be an in. Write your answer in. Okay. Recall I squared is equal to negative 1. So then we have 66 plus 15 minus 3i. So that gives us 81 minus 3i, which is the conventional answer, but you can also see that there's a GCF of 3. So if you see that and you want to go further, you would just pull it out and you would get 27 minus I. I'll accept either, but this is convention. Okay. And don't forget, we take the real part. We got to, distribute. So 9 plus 15i plus 4 minus 6i. And then we take the real part together. So that's 9 plus 4 and the imaginary part together. So that's plus 15i minus 6i. So we get 13 plus 9i. Okay. And then we're going to use quadratic to solve. So we get a equal to 1 here. B is negative 5. And C equal to 6. So we get x equals negative 5 plus or minus square root of negative 5 squared minus 4 times a times c all over 2 times a. So we get 5 plus or minus 25 minus 24 all over 2. So we get x equal to 5 plus or minus 1 over 2. That splits into 5 plus 1 over 2, which is equal to 6 over 2, which is 3. Let's make that 3 look a little nicer. And then you also have 5 minus 1 over 2, which is 4 over 2, which is 2. So you have x equal to 2 or 3. Okay. Now, I will warn you with the last one, your answer is going to have an I in it. I have a little note for you down at the bottom, but I just wanted to show you something similar. Unfortunately, I did not get one with an I in it, so I will just show you at the end, something to hopefully jog your memory about that. So first things first, let's get rid of the fraction. Let's multiply everything by 6. Because then that gets rid of all pieces of the fraction. So we end up with the 6's canceling and we get x squared here. Then we get plus 12x and then the 3 and that goes down to a 2. So 2 times 10 is plus 20 and then 0 still. So a is equal to 1, b is equal to 12 and c is equal to 20. So if we wanted to here, we could make it work better for us, but we're just gonna leave it as is, gonna show you how to work it, and then we'll change it kind of closer towards the end. So -12 plus or minus square root 12 squared minus 4 times a times c all over 2a. So x is equal to -12 plus or minus 144 minus 80 over 2. So that's x equals -12 plus or minus 64 over 2. So that becomes -12 plus or minus 8 over 2. Here the x splits, so it becomes -12 plus 8 over 2, which is -4 over 2, which is -2. The other option is -12 minus 8 over 2, which is -20 over 2, which is -10. So you're looking at x equal to -10, comma, -2. Now, what you need to remember is if you have a -1 under the radical, then you have an I. So even with the quadratic formula. So if we would have had instead -12 plus or minus square root of -64 over all over 2, then we would have a -8i under the radical, and that would end up being -12 plus or minus 8i over 2, which would end up actually giving you a different answer here. Sorry, let's expand this so we can see your example a little bit better. So if we would have been given, if instead from above, from number 25, I believe it was, yeah, we would have had worked it down to x minus 12 plus or minus 8i over 2. That's everything can get divided by 2. So GCF equal to 2 means divide by 2, divide by 2, divide by 2. So then you would have an answer here of -6 plus or minus 4i, and that would be it. Okay, so a little bit different of a situation there. That's more similar to what is on your exam. Just want to double check. Now they do split it a bit, so they did split, but I would give it to you like this. And do pay attention that if you cannot reduce it, or if you can reduce it but you still have a fraction on the bottom, so if reduce looks like, so let's say it's 6 plus or minus I over 5. Okay, then they wrote it as -6 plus I over 5, comma, -6. Well, I guess the minus would come first. Minus I plus I over 5. They wrote it more like that, but either is fine. And like I said, that is just extra stuff, which you will understand more if you watch this video. Okay, so that's for 25. And then, like I said, for up here at 10, You're looking at, you will have in your test answer. So you'll have a fractional exponent in your test answer. All right, so those are all the hints I'm giving you. This will be up on Canvas. You can watch it, you can fill it out. I recommend doing both. If we have time during class, I will certainly go through it. If not, I would recommend watching it over and over and making sure you understand it. All right, guys, it's been an absolute pleasure teaching you all, and I hope to see you guys in the future. See ya.